All right, here is the recorded version of what was supposed to be our online review session, our third one today. Unfortunately, there were technical difficulties, so I did the whole thing, but you don't see any of it. It's actually my third time recording this. I'm pretty sick of it, but hopefully this time it'll finally work. So the purpose of this review session is to review for quiz 5. Quiz 5 is kind of a big quiz. There's a lot of different topics on quiz 5. I mean, the general theme of it is it's solving equations, but there's lots of different types of equations, which means lots of different looking problems. So I try to grab some of each type of problem and we'll work those out here. So the first type of problem as I see it are what are called radical equations. You recognize radical equations, they're the ones with radicals in them, square root signs, cubed root signs, that kind of stuff. The key, maybe I'll write this up here, key to radical equations is to always check your answer. Always check answers. Why? Because they're difficult and you're going to mess up? No, actually. Because when you're solving these, you can do everything perfect and get your answers, and they won't all be actual answers. The process of solving radical equations, you lose information. And what happens is you end up with solutions that aren't solutions. Some of them work, some of them don't. You got to check them to make sure you got the ones that do work. Really, that only happens when you have even roots. What I'm saying are like square roots or fourth roots, not cubed roots. We really don't have to check our answers here, but here we will have to. Might be easier just to always check your answers. Anyways, the process of solving radical equations, what makes them hard is the radical, the square root. You want to get rid of the square root. To get rid of the square root, you have to isolate it. So in this specific example, to isolate the square root, I'd add x to both sides of the equation. That gives me 2x plus 10 is equal to x plus 1. Now that I have it isolated, I can eliminate it by squaring both sides of the equation. If you square the left-hand side, you end up with 2x plus 10. If you square the right-hand side, you get x plus 1 squared. Careful with x plus 1 squared. It's not x squared plus 1. Can't kind of distribute the square down. You have to do x plus 1 times x plus 1. Think FOIL. What you get when you square it is x squared plus 2x plus 1. So now I have an equation with no square roots, so now I have an equation I can solve. When you have equations that have squared terms and linear terms, what you want to do is set the equation equal to 0. So to set this equal to this 0, maybe I'll subtract 2x from both sides and subtract 10 from both sides. So let's see, if I subtracted 2x from both sides, I'd have no x's left. If I subtract 10 from both sides, I get here. Maybe I'll jump up, well, squeeze a little bit more in. So if you add 9 to both sides, what you get is x squared equals 9. I guess what you'd really get is 9 equals x squared. But I kind of like having my variable on the left, so I'll switch them. Add 9 to both sides, get you here. Then be really careful. You want to take the square root of both sides of the equation. When you take the square root of both sides of the equation, you got to put the plus or minus in there. That does not mean that every time you see a square root, it means plus or minus. It means when you take the square root of both sides, when you perform that operation, you have to add in this plus or minus here. So we get these two possible solutions. Maybe I'll switch colors. Possible solutions are what, x equals positive 3 and x equals negative 3. We have to check our answers, not because we made a mistake, because it's a radical equation. The way you check them, plug them back into your original equation. Check answers. You might be able to do it in your head. I'll write it all out. If I plug in 3 everywhere I see an x, I get the square root of 2 times 3 plus 10 minus 3 equals 1. This is true, this is an answer. This is not true, this is not an answer. See, 2 times 3 is 6. 6 plus 10 is 16. So is the square root of 16 minus 3 equal to 1? Well, the square root of 16 is 4. 4 minus 3 does in fact equal 1. So what I get is x equals 3 is a solution. What about x equals negative 3? Well, then it would be the square root of 2 times negative 3 plus 10 minus negative 3. And the question is, does that equal 1? Well, let's see. This is negative 6 plus 10 gives me positive 4 minus negative 3. That's the same as plus 3. Is the square root of 4 plus 3 equal to 1? No. Because the square root of 4 is just 2. 2 plus 3 does not equal 1. So what that means is this guy is not a solution. So this is the only solution. Don't forget that extra step, that when you're dealing with radical equations that have square roots, you have to check your answers. All right, moving on. What about this next one? This next one's similar, except now it's a cubed root. It's actually a little bit easier. If we're trying to solve this one, we want to get rid of the cubed root. To get rid of the cubed root, much like what we did above, we're going to have to isolate it. So to isolate it, add 2 to both sides. Cubed root of 4x minus 4 equals 2. All right, add 2 to both sides. Get rid of the cubed root by cubing both sides of the equation. 4x minus 4 equals 2 raised up to the third power. 2 raised up to the third power is 2 times 2 times 2, in other words 8. I can solve this equation by adding 4 to both sides and then dividing by 4. End up with x equals 3. You actually don't have to check your answer here because it's a cubed root instead of a square root, but if you feel like it, you can. 4 times 3 is 12. 12 minus 4 is 8. So underneath this cubed root here, I have 8. The cubed root of 8 is 2. 2 minus 2, sure enough, that's 0. But you don't have to check your answer on B here. You do on A. All right, C. C is difficult. What makes C so hard is we have 2 different square roots. So the process that we used above to get rid of the square roots we'll have to do, but we'll actually have to do it twice because you can only get rid of one at a time. So what you want to do is to get rid of a square root, you have to isolate it. So I don't know, maybe we'll isolate this one. The square root of 5 plus 4x equals 2 minus the square root of 2x plus 3. Now this one's isolated, so when I square both sides of the equation, it'll go away. What I end up with on the left is 4 plus 2x. What I get on the right is 2 minus the square root of 2x plus 3 squared. Good news, I don't have a square root anymore. Bad news, this thing's a mess. This thing will have a square root in it. Again, you can't just distribute this exponent. You have to think about it like FOIL. This is 2 minus the square root of 2x plus 3 times 2 minus the square root of 2x plus 3. So if I FOIL this all out, I get 4 minus 2 square root of 2x plus 3 minus 2 more square root of 2x plus 3. Negative square root of 2x plus 3 times negative square root of 2x plus 3. Negative times a negative is a positive. The square roots cancel out, and I'm left with just 2x plus 3. So when I combine like terms here, I got a 2x. See, I have a 4 and a 3, so I have 7. And then I have negative 4 of the square root of 2x plus 3 things. So all this work out to the side was just to figure out that on the right-hand side of the equation, I really have 2x plus 7 minus 4 times the square root of 2x plus 3. This is a mess, but it's actually better than what we have up here, because up here I got 2 square roots, down here I only have 1. I can get rid of a square root if there's just one of them, isolate it, and square both sides of the equation. Okay, so repeat that whole process again. Get this all by itself. Maybe add it over to this side and get 4 square root of 2x plus 3. And I subtract 5 from both sides. Subtract 4x from both sides. You get negative 2x plus 2. So I added this one over here. I subtracted this. 7 minus 5 is 2. I subtracted 4x. 2x minus 4x is negative 2x. That gets me here. You could square both sides of the equation right now, but since I've been telling you to isolate the square root sign, I guess I should do that. So let's divide both sides of the equation by 4. That gets me here. Negative 2x divided by 4 is negative 2/4 x, but negative 2/4 is 1/2. Similarly, this 2/4 is 1/2. Now I can get rid of the square root sign if I square both sides of the equation. To square the right-hand side here, maybe I should be using a different color. I have to figure out what is negative 1/2 x plus 1/2 times negative 1/2 x plus 1/2. Well, negative 1/2 x times negative 1/2 x is positive 1/4 x squared. Negative 1/2 x times 1/2 is negative 1/4 x. 1/2 times negative 1/2 x is negative 1/4 x. And 1/2 times 1/2 is 1/4. So what I get here is 1/4 x squared minus 2/4 x. 2/4 is the same as 1/2 plus 1/4. So back over here in blue, I got 2x plus 3 is equal to, I expanded this out over here to figure out it's 1/4 x squared minus 1/2 x plus 1/4. All that work, I finally have an equation that doesn't have any square roots in it, so I can solve this equation. A couple different ways you can solve this. I don't like fractions. Assume you don't. Most people don't. We get rid of all the fractions if we multiplied both sides of the equation by 4. Clear the denominators is the name of that little trick. So if you multiply this side by 4, we get 8x plus 12. If you multiply this side by 4, we get x squared minus 2x plus 1. You don't have to do it that way, but it's a convenient little trick. Now what I want to do is set this equation equal to 0, so subtract 8x from both sides and subtract 12 from both sides. Gives me x squared minus 10x minus 11 equals 0. And to solve this equation, you got to factor two numbers that multiply to negative 11 and add to negative 10. Negative 11 and positive 1. So this tells me that either x minus 11 equals 0 or x plus 1 equals 0. So x equals 11 or x equals negative 1. Finally done with that horrible problem? No, you are not. Because we got to check our answers. Anytime you got square roots, got to check your answers. Got to plug both of these back in. Check answers. This problem is very difficult. The one on the quiz will be very similar to this, if that helps at all. Check your answers. Okay, if x equals 11, maybe I'll just talk through it. 4 times 11 is 44. 5 plus 44 is 49. The square root of 49 is 7. When x equals 11, this thing right here is 7. 2 times 11 is 22. 22 plus 3 is 25. The square root of 25 is 5. So I got 7 plus 5. Is 7 plus 5 2? No, 7 plus 5 is 12. 11 is not a solution. What about negative 1? 4 times negative 1 is negative 4. Plus 5 is positive 1. The square root of positive 1 is 1. This whole thing is 1. 2 times negative 1 is negative 2. Plus 3 is positive 1. The square root of positive 1 is again 1. 1 plus 1, yeah, that's 2. Negative 1 is a solution. So negative 1 is my final answer. Wow, that's a lot of work. All right, moving on. Probably the hardest problem that you'll see on this review session. How about definitely? Okay, another type of equation that you want to be familiar with solving is when you don't have radicals like we had up here. Two different types, I suppose. One type is when you can, well, when your method will be to isolate x. What do you mean by isolate x? Well, if you can rewrite this only using the letter x one time, then you can just isolate x to solve. So what I mean is, if we subtracted 4x from both sides of the equation, we get 2 equals 8x squared. I have now rewritten this only using the letter x one time. That tells me that the way I'm going to solve it is by isolating x. I really want to differentiate that from like this problem, for example, that you can't write in that form because the strategy that you'll use will not be to isolate x. It'll be a different strategy. But up here, we just want to isolate x. Want to get rid of this 8, want to get rid of this squared. Divide both sides by 8, you get 2/8 is x squared. But 2/8 is just 1/4. So 1/4 is x squared. So if I take the square root of both sides of the equation, and I remember that every time I take the square root, I got to put in a plus or minus. I get x is plus or minus the square root of 1/4. However, the square root of 1/4 is the square root of 1 divided by the square root of 4. Square root of 1 is just 1. Square root of 4 is 2. So what we get for our answers are plus or minus 1/2. You can check your answer if you feel like it, but you don't have to. You only have to on that first type of problem. So yeah, plus or minus 1/2, final answer. That's it. All right, what about this next one? This next one I put right after this one to really emphasize. Up here we could isolate x to solve because we could write it only using x one time. Can't do that down here. When you can't do it, your strategy will be to set the equation equal to 0. When you set it equal to 0, so 6x cubed minus 5x squared minus 4x equals 0, if I subtract 4x from both sides of the equation, I can now factor to solve this thing. The way you factor is, first, every time you're factoring, look for a greatest common factor. In this case, all three terms have an x in common, so I can pull that out and rewrite the equation like this. I now have something times something else equals 0. The only way you can multiply two things together and get it to equal to 0 is if one of those two things equals 0. So what I'm saying is, if x times this thing equals 0, either x is 0 or this thing is 0. So I got one solution at x equals 0. This one I don't have the solution yet, but I can solve this. Solve this by factoring. Maybe I'll do that over here. To factor 6x squared minus 5x minus 4. What you want to do, there's a couple different ways to do this. The way I think is easiest is a three-step process. First, find two numbers that is going to multiply to the product of a and c, to the coefficient on x squared and your constant term. 6 times negative 4 is negative 24. I need to find two numbers that multiply to negative 24 and add to negative 5. Negative 5 being the coefficient on the x term. So let's see, what multiplies to positive 24? 1 times 24, 2 times 12, 3 times 8, and 4 times 6, if I'm dealing with integers. If it's going to multiply to negative 24, I take one of these pairs and make one of the numbers positive and one negative. If I need it to add to negative 5, the only pair I can choose is this 3 and 8 here. Let's see, I would have to make the 8 negative and the 3 positive, plus 3 minus 8. Find two numbers that do this. Here's two numbers that do that. Step 2. Replace your middle term, your negative 5x, with kind of what you just found, plus 3x minus 8x. Okay. 6x squared minus 5, Instead of 6x squared minus 5x, 6x squared plus 3x minus 8x minus 4. Instead of writing minus 5x, I wrote plus 3x minus 8x. Step 3, factor by grouping. Factor by grouping, what you do is first look at your first group, these first two terms here, and look for their greatest common factor. Let's see, in this case, 3x. If I pull a 3x out of this term, I'm left with 2x. If I pull a 3x out of this term, I'm left with just 1. Now what I got to do is pull something out of this next group. You always have to pull out something, even if it's just a 1. Pull out something so that you're left with 2x plus 1. In order to be left with 2x plus 1, I'd have to pull out a negative 4. What I now have are two terms that both have a 2x plus 1 in them. If you pull out that 2x plus 1, this is gone and this is gone. Now what you have left is 3x minus 4. All that work just so I can write right here 2x plus 1 times 3x minus 4 equals 0. All this work on the side was just to factor this out because I want to factor to solve this. What I now have are two things multiplied together that equal 0. That tells me is either 2x plus 1 equals 0 or 3x minus 4 equals 0. So either 2x equals negative 1 or 3x equals positive 4. Either x equals negative 1/2 or x equals positive 3/4. Be a little bit careful here. You might think that these are your answers. Not quite right. These are answers, but they're not all your answers because up here we found that x equals 0 was a solution. Got 3 different answers to this equation. All right, moving on. When you get a problem, number 4, that looks a lot like number 3 in that we can't write it only using the letter x one time as we did in number 2. When you get one of those problems that doesn't factor, either because it just doesn't factor or because you can't get it to factor, you have 2 different options. So when factoring fails, you can either use the quadratic equation or you can complete the square. Most people think this is easier. Either one will work. These are actually the exact same thing algebraically. Anytime one will work, the other will work. Most people like this one. The advantage to this one is later on in the class we'll have to do this. This will be something we need to figure out. So it might not be a bad idea to learn it now since you're going to have to learn it anyways. But it's up to you. Either one will work. The quadratic equation is kind of a memorization thing. It says that when you have an equation of the form, keep trying, ax squared plus bx plus c equals 0, the solutions will always be negative b plus or minus the square root of b squared minus 4ac all over 2a. Memorize. If you got this memorized, you can do it. If you don't have it memorized, you have no chance. There's little songs that people remember. Do whatever works for you. One way or another, if you want to use the quadratic equation, you got to have this memorized. If you have this memorized, then what you do is you go up to this question, x squared minus 5x equals 5, and you notice that it's not in the right form. This equation gives you solutions to equations of this form. We need it to be equal to 0. I got to subtract 5 from both sides of the equation so that it fits this form. Now that it fits this form, I can say that a is equal to 1, b is equal to negative 5, and c is equal to negative 5. A because a is the coefficient on the x squared term, which is 1 here. B is the coefficient on the x term, negative 5. And c is the constant term, also negative 5 in this case. So what I do is I go back to my quadratic equation, and instead of writing b, I write negative 5. Instead of writing a, I'll write 1. And instead of writing c, I'll write negative 5. If I can simplify this thing, it'll give you my answers. Negative 5 is just positive 5. Negative 5 squared is 25. Minus 4 times 1 times negative 5. 4 times 1 is 4. 4 times negative 5 is negative 20. Minus negative 20 is the same as plus 20. 2 times 1 is just 2. So what I get is 5 plus or minus the square root of 45 divided by 2. Final answer? Well, kind of. This 45 can simplify. I mean, realistically, if you got to here, I'd be pretty happy. I'd probably give you full credit. But just for the sake of the computer program, you might want to simplify this 45. The way you simplify that 45 is by noticing that the square root of 45 is the same as the square root of 5 times the square root of 9. And the square root of 9 is just 3. So the square root of 45 is 3 root 5. So here are our two answers. 5 plus 3 root 5 over 2, and 5 minus 3 root 5 over 2. Okay, what if you were to complete the square? I'm going to do this exact same problem, a different method. You really only need to know one of these two methods. To complete the square, it's I don't know, I guess it's a 3-step process. Step 1, make the coefficient on x squared equal 1. I guess it's a 4-step process. Step 1, done. We don't have to do anything. The coefficient's already a 1 here in this problem. If it weren't, if this were 2x squared minus 5x equals 5, I'd have to divide everything by 2. But in this case, it's not. The leading coefficient is a 1. Make the coefficient on x squared equal 1. Done. Step 2, isolate x squared and x terms, calling the coefficient on x b. What I'm saying here is make it so that the x squared and the x term, 5x in this case, are by themselves. In this case, they already were. If it said x squared minus 5x minus 5 equals 0, I'd add 5 to both sides so that they're isolated. Isolate the x squared and x terms like I have here. And at this point, and only at this point, do you name b. b is equal to negative 5. It's tempting to look at the problem originally and name b. You'll get the wrong answer if you name b too early. You don't want to name b until after you make the coefficient on the x squared term equal to 1. So b over here is a little different than b over here. Okay, step 3. Add b over 2 squared to both sides. So if b is -5, b over 2 squared is -5 over 2 squared, which is 25/4. So what I'm going to add to both sides is 25/4. X squared minus 5x plus 25/4 is equal to 5 plus 25/4. Why? Why am I adding 25/4 to both sides of the equation? The reason comes in step 4. By adding 25/4 to the left, what I'm left with over here is a perfect square. X squared minus 5x plus 25/4 is a perfect square. It's x plus something squared. Replace the perfect square. How about replace the left side? Let me reword this so it's more obvious. Replace whatever. Replace the perfect square. Can't think of a better way to say it. Maybe I'll say hint. It will always be x plus b over 2 squared. What I'm saying is what I've written on the left side of the equation here, that x squared minus 5x plus 25/4, that is equal to x plus, let's see, b over 2 is -5/2, so plus -5/2 squared. This is the same as this. It's hard to see that this is this, that's why this hint is helpful. If you started with this, you could probably FOIL everything out and get back to here. But what you want to do is change this into this. We've now completed this square. It's a little bit memorization-y also, but it's helpful. It's something you'll have to do later in this class. At this point, I only have the letter x written one time. If you only have the letter x written one time, you can solve just by isolating. What I'm saying is I want to get x all by itself. Maybe I'll first combine like terms over here. 5 plus 25/4. See, 5 is 20/4. 20/4 plus 25/4 is 45/4. If I want to get the x all by itself, I got to get rid of this squared by taking the square root of both sides of the equation. Don't forget that when you take the square root of both sides of the equation, you have to put in this plus or minus. So I got x minus 5/2 equals plus or minus the square root of 45, as we saw earlier, is 3 root 5. And the square root of, man, it's hard to write on a computer. Square root of 4 is just 2. So if I want to solve for x, I just have to add 5/2 to both sides of the equation. X is 5/2 plus or minus 3 root 5 over 2. This is equivalent to this up here. Get the same answer, 2 different ways. Do it either way. This way is probably easier for now, but this way will be useful later, so you might want to bite the bullet now so it doesn't suck later when you're trying to learn this. All right, a few more problems. Substitution. The idea with substitution is you'll be given a problem that is pretty close to, I don't know, this type of problem. How about this part of this type of problem? You'll be given a problem that's pretty close to this thing. 6x squared minus 5x minus 4 equals 0. You'll be given a problem that's close to a quadratic trinomial, which we can solve by factoring. The problem is it's not a quadratic trinomial. In this case, it's x to the 4th minus 5x squared plus 4 equals 0. What we want to do is come up with this substitution kind of cleverly, pick some other letter, y maybe, and let that be equal to something. In this case, that something's x squared. I'll explain why I got that in just a minute. So that if you replace x squared everywhere you see it in the above equation, you end up with a quadratic trinomial. All right, what I'm saying, this deserves a lot of explanation. First of all, notice that x to the 4th is the same as x squared squared. When you have exponents raised up to exponents, you multiply them. This is the same as this. But this form makes it a little bit more clear that if I could just change these x squareds, this one and this one, both into y, what I will have is a quadratic trinomial. I'll have y squared minus 5y plus 4. I'll have something that I can factor and solve. Figuring out that substitution is a little bit tricky, but once you get that substitution, the problem flows along pretty nicely. Factor this and solve it. Because my leading coefficient is 1, I just need to find two numbers that multiply to positive 4 and add to negative 5. Negative 4 and negative 1 in this case gets me here. So either y minus 4 equals 0 or y minus 1 equals 0. I've just solved and figured out that either y is 4 or y is 1. Done? No. Because y is something I just invented, right? Y I'm calling x squared, but that wasn't in the problem. This problem didn't have any y's in it. It's just something that I did. So what I got to do is I got to substitute back. I got to make up for the fact that I just changed the problem to make it something I could solve. Change it back. Y is really x squared. This is really saying x squared equals 4, and this is saying x squared equals 1. So if I want to solve for x, I take the square root of both sides of the equation and get x is plus or minus 2 here, and x is plus or minus 1 here. So this substitution method, I mean, it's kind of clever, I guess. It's a little bit hard to see. You have to be clever on which substitution you do. It's not obvious all the time how to substitute, but you want to come up with some sort of substitution that will change the problem from this into a problem that you can solve, even if you're solving it with a different variable, because you can then later change back into the variable you want. I kind of thought that people would struggle with that, so I gave two examples. I gave another substitution example down here. Same thing. This isn't something we can solve. It kind of looks something like a quadratic trinomial, kind of like this. Your task is to look at this and figure out what should we let y be equal to make this look something like this. The trick for this one is noticing that x to the 1/3 squared is the same as x to the 2/3. Right? When you're raising exponents to exponents, you multiply them. 1/3 times 2 is 2/3. So really what I have here, what the problem gives me, is this. And so what I can do is maybe let y equal x to the 1/3 power. So what I get is y squared minus 2y minus 3 equals 0. This is a problem I can factor, I think. Two numbers that multiply to negative 3 add to positive 2. It's that negative 3 and positive 1. So I get that either y minus 3 equals 0, in which case y equals 3, or y plus 1 equals 0, in which case y equals negative 1. Not done. Remember, y is something I just invented. I got to make up for the fact that I changed the problem from something I couldn't solve into something I can solve. So what I got to do is, instead of y equals 3 and y equals negative 1, I really have x to the 1/3 power equals 3, and x to the 1/3 power equals negative 1. To isolate x, I could cube both sides of the equation. X equals 3 cubed, in other words 27. And x equals negative 1 cubed, in other words negative 1. So for my two answers, I'd say x equals 27 and x equals negative 1. So I don't know, substitution a little bit tricky. This will 100% be on the quiz. You'll just have to make the proper substitution to turn it from a problem you can't solve into a problem you can solve, and then don't forget to substitute back at the end. All right, last thing I want to talk about, the discriminant. The discriminant is something you use not when you're trying to figure out solutions to the equation, but just when you're trying to find out how many you have. Okay, so first thing, discriminant. The discriminant is b squared minus 4ac. It's the thing in the quadratic equation, where am I? The thing in the quadratic equation underneath the radical, b squared minus 4ac. So note, I don't have any square roots or any of the rest of the quadratic equation, just this stuff. This stuff is called the discriminant. If b squared minus 4ac is greater than 0, you get two solutions. Doesn't tell you what the solutions are, just tells you how many. If b squared minus 4ac equals 0, you only get one solution. If b squared minus 4ac is less than 0, you get no solutions. Actually, you get no real solutions. But for our purposes, we're talking about real numbers again. We went into complex numbers on the last quiz. We're done with that for a while. We're back to just real numbers. So all you're doing on these discriminant problems is get it into the form ax squared plus bx plus c equals 0. It's kind of nice and started you in that form for all three of these. Determine what a is, determine what b is, determine what c is. A is 1 because there's a 1 in front of this x squared, b is negative 1, and c is negative 12. Plug that into the discriminant. Discriminant equals b squared, negative 1 squared, minus 4ac. 1c. 4 times 1 is 4, times negative 12 is negative 48, minus negative 48 is the same as plus 48. The discriminant is 49, which is greater than 0. Therefore, I get 2 solutions. If your discriminant is a perfect square, you get 2 rational solutions. It's not a perfect square, you get 2 irrational solutions. I'm less concerned with that. I just want to know how many solutions you get. If you're curious why this works, you can kind of get it out of this quadratic equation. If this thing in here is a positive number, then its square root is a positive number. And so what I'm doing is I'm adding a positive number to negative b, and then I'm subtracting a positive number from negative b. I'm getting 2 different answers here. If this b squared minus 4ac thing is 0, the square root of 0 is just 0. So I'm taking negative b and I'm adding 0 and then subtracting 0. But adding and subtracting 0 are the same thing. It's not giving me 2 different answers, just give me one answer. If b squared minus 4ac is a negative number, then what I'm trying to do is take the square root of a negative number. Can't take the square root of a negative number if you're just dealing with real numbers. So you won't have any real solutions. Anyways, I don't know that you need to know why the discriminant works, but that's why it works in case you're curious. If we go through those same steps down here, a is 1, b is negative 2, c is positive 1. A is 1 because there's an implied 1 here, b is negative 2 for this negative 2, c is 1. B squared minus, how about discriminant equals b squared, negative 2 squared, minus 4ac. Negative 2 squared is 4, minus 4 times 1 times 1 is 4, 0. Therefore, there's only one solution. If you factor this, it will be x minus 1 times x minus 1. So you'd say x minus 1 is 0 or x minus 1 is 0. In other words, x is 1. There's only one solution here. All right, final problem. Hopefully the final time I do this final problem. Same idea. A is equal to 1. B is equal to negative 1. C is equal to 2. Discriminant is b squared minus 4ac. Negative 1 squared minus 4ac. Negative 1 squared is positive 1. Minus 4 times 1 times 2 is 8. This equals negative 7. Negative 7 is less than 0. Therefore, no real solutions. That's all you need to know about the discriminant. Just the point that I want to make is the discriminant does not give you the answers, just tells you how many answers there are. That's all you'll need to do with the discriminant on the quiz. If all these examples make sense, I think you'll do pretty well on the quiz. I think this week's quiz is a pretty hard one. There's lots of different types of equations to solve. But hopefully this is helpful for people. Hopefully when I post this actually works and I won't have to record this again. I guess that's the end of this review session.